Hi guys, welcome to lesson 4 in exceptions. What we're going to do is we're going to have a look at the multi-catch block that was introduced in 7. So let's get about it. Okay, so what I've got here is in these examples that I'm going to do now, I want an IO exception and a number format exceptions to be caught, and the eGet message to be printed to the console. So in my little application, it's going to throw possibly an IO exception or a number format exception, and I want that method to catch those exceptions. In the real world, one would have these logged so that the programmer could then work on the errors. Okay. What I'm going to do, I'm just going to throw a runtime exception. Okay. After that, I just throw a runtime exception that is caught by the client. In this case, my client will be my main method. So see the main method is a client for the simulated little application. It could just as well have been another package, in another package, a GUI and so on, written by another program and so on. So what I'm trying to say here is, let's go to my first test case. Okay. Test 1. Okay. Just going to open this here. And here we're going to catch multiple exceptions. Okay. So what I'm doing here is I'm passing in a file name as a string. And then here I've got to try catch. And I've got a multi-catch. As you can see, I'm catching an IO exception here, input-output exception, usually related to files, reading files and so on, and a number format exception, which is usually got to do with when you pass a string to something else and so on. Okay, so in this try, I'm calling the files class its method called read all files, or lines, read all lines, and it reads all the lines in that file, and every line is stored in a list, a collection list of strings. Okay, and here I'm using this file name here, you see, and I'm creating a path here. Paths get, and I'm using that file name to create a path, because the file uses a path object to read. Then it opens that file and it will read one line at a time. Okay, and then let me just show you what the files look like, just to give you an example of one of them. I'm going to open this one here. In this one, I've got a file that reads 1, 23, 12 and so on. And then I've got another file that reads 2, 3, and then instead of a number it's reading NaN, which is short for not a number, but it could be any text, any character you wanted there. Okay, so those are the two test files I've got. Okay, so what's happening, I'm initializing a local variable of type integer to sum, called sum to 0. Then I'm using a enhanced loop, and I'm going through each of these lines that's in the list of strings, and I'm reading a line at a time. So I'm reading one line at a time, and I've created this so that there's only one character in each line, or one integer in each line in this case. Okay. And then what I'm doing, because this is a character string, a character text file, this here reads character files, strings in other words, I'm converting that string. So I would convert to the character 1 to its corresponding number 1, integer 1, and 23 to corresponding integer value of 23 by using the integer static method, class method called value of. Okay, now if this value that I'm passing here cannot be converted into an integer, it will throw a number format exception here. Now, if the read all lines for some reason cannot open or cannot read the file, then it will throw an IO exception. Okay. Then what I'm doing is, if everything works, I will then print the sum, because I'm adding to the sum. I'm summing the total of all of them. I'm reading a line at a time. So it's 1, 23, 12 and so on. And this operator sums it up. So the first time it reads, it will be 1. The next time it will have stored 1, this plus equal here. And I'll add the 23 and the next loop 12 and so on. It will come to a total, I think it's of 61. Okay. So what's also important here, if I say an IO exception is called, it will print the message, it will retrieve the message from that exception, it will print it, and then what I'm doing is I'm throwing a new runtime exception. And this runtime exception, if you go and look at the main method, the call to, this is the client, the call to my method will then catch it. If it isn't called, that runtime exception thrown, it will come here, it will be in the try, but I'm only catching a null pointer exception. So it won't be, a runtime exception won't be caught here, because this is a null pointer exception, which is more specific. So then it will propagate all the way to the main method, and as it's a runtime exception, you don't have to catch it or declare it, but your main method would then, I'm just going to blank this in the meantime, clear it, it would then catch it, the virtual machine will catch it. Okay, so let's try this one, and the first test I'm going to do, I'm going to pass a test called test1, and I'm going to pass it the file name no such file, which means it doesn't exist. I don't have such a file, no such file. Okay, so let's see what happens. So if I run it, and I did get an exception, and if you look here, the first line that's printed is no such file. And if you look here, there is no such file, so it would have come from trying to read the file, trying to open the file and so on. So it will throw an IO exception. And here it prints this message, no such file, which comes from the input-output exception. And then I throw a new runtime exception, which then propagates all the way to the main method. And the main method here, you'll see, it throws an Java NIO file, no such file exception with its message. Okay, so that's working fine. So if I look here, what I tried and say, what I did there is either catch a number format exception or the IO exception. I caught the IO exception in this case because that was what was thrown, and then I then read through the runtime exception, which went all the way down to the main method, which didn't catch it as it's not a null pointer, and the Java virtual machine then eventually caught it and threw it out. Okay, so let's see the next example with this test case one. Now if I'm just going to comment that one out, and I'm going to run the same application but with resources numbers.txt, and this is my numbers.txt, which is in my resources folder. So I've just got numbers in there. So let's see what happens if the program works. There, and it ran through, it read it like I explained earlier. It started with 0, read each line, 1, 23, 12, added them all together, and if you go and add them all together, you'll see it's 61, and that is, it printed out the sum is 61. So no problem there. Okay, so it's working fine. So I've managed to catch my IO exception in the case where it was an IO exception, and if there's no exception and it worked fine, what happens to number format exception? and you'll see this one has got a nan here, so it should sum 2, 5, and then it will throw a runtime exception over there, a number formatted exception actually. So let's go and look at that one. And to do that one, that will be my next test case over here. So I'm going to call test 1 again, the same method, and I'm going to call numbers 2, which is this one, this file. So let's see what happens in this case. I'm going to run it, and let's see. It told me, gave me a new message for input string nan. So it's telling me that it came here. When it read and read, and it came to this one, which is not a number. It cannot format it to a number, from a string to a number. So it stopped there, threw an exception. This line didn't get called anymore. It didn't get called here. It got called here at the number format exception. And it printed this message here from this line here. And then as you can see, I threw a new runtime exception, and you'll see here it gets called by the virtual machine because I'm not catching it here. So it gets called by my virtual machine, the main method. It propagates all the way up, and you see I threw a runtime exception, and in this runtime exception, if you look at it, in the runtime exception, I attach the original exception, which is the number format exception here. And you see there it tells you it threw a runtime exception, and basically caused by the number format exception, which got a message of the input string nan. Okay, so far it's doing what I wanted it to do. I wanted it to catch my IO exception and my runtime exception, and my number format exception. And I'm throwing a runtime exception afterwards. But what happens if I throw an exception that's not an IO exception or a number format exception? What should happen then? It should propagate. It shouldn't be caught here because I'm not catching it here. I should let the client handle it. So let's see, here in this client code of mine, I've got a try, and I'm actually catching a null pointer exception here. So let's see if I pass it a null pointer exception. And the easiest way for me to do that is in my next test, is when I pass a file name, a string here, I'm going to pass null instead. Now if you pass null and you try and read a null file, it's going to give you a null point exception, which is a runtime exception, and it's not going to be caught here or there, as you can see. So it's not going to throw anything because it's going to be thrown from there. It's got no catch here, so it's a runtime. I don't have to declare it, but it's still going to come down here. And yeah, remember runtime, null point exception is a runtime exception. I can catch it if I wanted to or not. And in this case, I am opting just to illustrate. So I'm catching it here, null point exception, and yeah, I'm actually saying that the client has caught it, and the client is handling this exception. So let's see what happens. Let's see, there is going to work. Let's see, and there, the client has caught null. So let's go through it again. I'm passing null to here. Null is coming here. When it comes in here, it's going to throw a null point exception at this line because it's trying to get null over here, which is not going to work in this code here. So it's going to throw a null point exception. These don't run because that doesn't catch a null point, only catches an IO and a number format exception. Comes all the way back from where it was called. It's in a try block. The try block catches the null point exception, and there it prints out the message. The client has caught, and the message that the null point exception is throwing out is null. Okay, so this is the first test case. So let's look at the next one. Okay, so now that we've done the first 3 tests, what is the issue with this code? I mean, if I look here, my requirement is to catch IO exception and the number format exception, one or the other, and any other exception must be caught by the client, in this case my main method. So everything is working fine here. So is there any issue with this code if you look at it? If you look over here, okay, these 2 lines over here, and look at these 2 lines over here, they're identical. That means I've got duplicate code. And one of the principles of object programming is to eliminate duplicate code, because as we know, duplicate code you could have are prone to errors, especially if you had a lot of more code down here, more exceptions and so on. You could end up changing code on one of these and not changing it somewhere else where you had to change it, and which causes errors in programming logic and things like that, which make it difficult to find later. So yeah, although our requirements are met, we are violating one of the principles, and that is to eliminate duplicate code. So how will we go about eliminating duplicate code? Now, I've done this for many years and as a mistake. So let's see. Yeah, on test 2, what I've got here is I'm passing the file name as a string, the same code over here, but you'll notice instead of catching the multiple extensions here, multiple catches, I'm using one catch, and I'm catching everything in my super class of all extensions called exception. So this will catch any runtime or caught exception out there. So why is, when I put this in big, why is this bad? Why mustn't I do this? Let's go and see why I say this is bad. Because if you see, I've eliminated duplicate code here. I've only got 1 line of code where here I had 2 exceptions with the same code in it. Okay, let's just do the test quickly to see. So if I do test 1, which I want to catch a no such file exception, an IO exception, and if I run it, okay, so what's happening here? Let's go and look. No such file exception gets caught over here. I print the message, and it gets caught again in the main method. Okay, now this seems to be fine. So what is the issue then? Let's try the next one. I'm going to see if this one works. Let's save it. Oh, and that is working. So there's no exception thrown. It did everything as it's supposed to do, and as there was no exception thrown, that's fine. So let's do test 3. This one will then throw a number format exception. That one was an IO exception. Let's see if it catches the number format exception. Well, and it caught, there it is. It's printing it out. Did catch it, and then it did throw it, so it's doing exactly what it was supposed to do. It caught my number format exception over here, printed the message because it's part of the superclass caught it, and I rethrew it, and it's behaving exactly the same as before. Let's try the next one, which we are going to throw a null pointer exception. So let's try the next one. Let's see what happens here. Oh, look what's happening now. If you look here, I'm passing a null exception here. I'm passing a null value here. In this code here, it's going to throw a null pointer exception, which is now caught by its superclass. And here we got an issue. Remember my requirement in the beginning that is violating my requirement, because in my requirement I just want to catch an IO exception and a number format exception. Okay, exception. Okay, so what's happening here is, remember I'm a programmer and I was given just the one class to write which would do a specific function, and that function had to catch basically the IO exception and the number format exception, no other exception. Those exceptions had to be caught by the client. That's the requirement. So what's happening here is this method of mine is catching every single exception, including my 2, but every other exception. So it's not meeting the requirement of my method or my program. Okay, so this is the major issue with using, and why I say don't do this. This is bad programming. I've been doing it for years until you understand it, but it's bad to catch an exception superclass. Always try and catch the most specific possible exception. In this case, this one throws an IO exception. So in my code, I would catch an IO exception, and as this code here can throw a runtime exception of type, you could opt to catch it or not, and my requirement says I will catch it, so I catch the number format exception here as well. I don't catch any other exception because it's not in my requirement. Okay, so that's why this is bad code. Okay, so pre Java 7, how we used to try and eliminate duplicate code is to take the duplicate code and put it in a method or class in its own, and then just call that method. So that's what I'm going to show you in test 3 and see how it works. So here I've got test 3, which is the same thing. You sending a string and you're reading the file, summing it up, and throwing an IO exception or a number format exception. And what you'll see, the difference here is I've got a method here called handle exception. So yes, there is duplicate code, but remember this could be code of say 100 lines in here, and now you've just got one line calling a method. So you only do this once, one line, and the chances of doing an error here is much less. What I mean is, if you go and look, all the code is changed in one place in a utility method here. So whatever changes there will be that will happen, it will be done just in one method instead of me having to change in various catch, whatever the case would have been. So let's see what this does, if this meets our requirement of just catching an IO exception and a number format exception, and any other exception must be handled by the client. So let's see that. Now yeah, we are on test 3. So let's see. As you can see, I'm catching an IO exception here and a number format exception, and any other exception will be propagated back to the client. Let's try that. So we'll do the test 3 with a no such file. So there's no file, so it should throw an IO exception. Let's run that, and there's it. No such file is thrown there, which is what I was looking for on test 3. So it's catching an IO exception here, and this IO exception is calling handle exception method with a reference, with the exception, a reference to the original exception. So you see I'm passing an exception here. That's important because yeah, I'm using that reference to that exception to print this message, which is exactly what I wanted, and I'm throwing a runtime exception again, which is then caught by the main method, the client in this case. Okay, so that is working 100%. And if we test the other one, just to see, if we test now with an existing functional file, which is that file there, let's see what it does. Oh, it's working 100%. And let's do this one. one that would throw a number format exception. It should throw it when it reaches that line there, when it reads it. And yes, it's throwing, and it's throwing the right information again. It's throwing the information here for, so it's coming here, it's catching a number format exception. It's calling my exception handler, and as I pass the exception information here, it's printing the right exceptions information here. You see there? Yeah, this one would print the IO exception because I'm passing the IO exception here, and yeah, number format exception, I'm passing a number format exception here, and that is what it's printing out there. And then I'm rethrowing a runtime exception with that same exception reference there. And there's a tease on the main method. It's throwing the right, and it's telling you what's happening there. So it's working 100% there. Let's try the null pointer, and remember the null pointer mustn't be caught by my method, must be caught by the client, and we see this as the client here. The main method is our client in this case. And let's see what's happening. And the client has caught a null. It's exactly what I wanted. I wanted the client to catch it, and not my my test my method or my class, whatever this would have been, but in this case is my method. So I didn't want it caught here. It hasn't been caught here. So this test case, this test 3, fully conforms to my requirements, and I'm eliminating to a great extent duplicate code. Obviously there's still this duplicate code here, and I could have maybe another line here and so on, calling another method or 3 or 4 methods, utility methods, but I am let's say minimizing the amount of duplicate code. Yes, it's not, there is still a bit, but much better than my previous examples. Okay, now Java 7 introduced the multi-catch statement, and the main reason for that was to reduce duplicate code. Okay, so let's look how they went about it, the Java designers. Yeah, I've got test 4. As you can see, I'm doing the same. I'm passing a string file name, and then in the try catch, what's happening here is they brought the multi-catch, which I can catch 2 or more exceptions separated by which they call a pipe. So I've got an IO exception here, number format exception here, and I could have another pipe, another exception. But my requirement, as you recall, is 2 exceptions, the IO exception and the number format exception. Then my code comes in one block over here. Instead of having 2 different catches, I've got one catch which can catch multiple exceptions. Okay, here is my exception reference variable, and I'm printing the message, and then I'm throwing runtime exception again as usual. So let's see what happens if I do this. That is test 4, so we're going to run test 4 here with a no such file. So it should throw an IO exception. Let's see, yeah, there is my message, and then I read through it. So if we go look here, it comes here, it doesn't find that file, so it throws an IO exception. No such file exception found, no such file exception there. It's caught here in the IO exception, and the reference is passed eGet message. There the eGet message prints out that message there, and then I'm rethrowing it, and my main method is catching it. It's propagating to the main virtual machine, and it's throwing a runtime exception with the Java NIO file, no such file exception with this message. Okay, so that seems to be working fine. So let's run the other tests to see what they do, if they fulfill my requirements. So we're going to run the one that passes in a valid file with a lot of numbers. Let's do that and see. Yes, that's working fine. Test 4. That's working fine. So let's try with an invalid file. What I mean is that one that will throw a number formatted exception, and there's a number format exception in my multi-catch, so I should catch it here. So let's see if I run it, and there it did catch it. There's my message, and then I throw the runtime exception again, and then the main method propagates all the way to the main method. So that's working fine. That's quite cool. And then let's do the last one, which I pass a null point exception. Recall a null point exception in my requirements must be called by the client, in this case the main method. And so let's see, I'm not catching any null point exception, so it shouldn't be caught here. So let's see what happens. And yes, it's working 100% as we had it before. It's catching it here and it's printing out that. So yeah, so here we got Java 7 was introduced a multi-catch statement to reduce duplicate code, and you can see all my code is in here, so I've got no duplication of code at all. So that's working fine. Okay, now that we looked at the multi-catch in the try catch finally, I want to show you guys some rules on the syntax of the multi-catch. Okay, yeah, I've got a test 5 here, but what I want to show you guys, I've got a try with catch here, but I've got arithmetic exception and E1 there, pipe an illegal argument exception E2 there, and it's giving me a compile error. Okay, now this won't compile because note the syntax. The syntax is try with a multi-catch, the first exception with the OR symbol or pipe, if you want to call it that. The next exception, it will have another pipe there, third exception, and so on. And there will only be one variable for all of the exceptions, variable reference at the end. So note that. So if you look at this example, yeah, this one wouldn't compile because I've got the same variable but in two places. So I'd have to take that one out, otherwise it won't compile. And yeah, I gave it two different variable names, it also won't compile it. Just one variable name at the end. Okay, so that's rule number 1. Okay, yeah, on test 6, method 6, I've got another example of an multi-catch that's not working. I've got a multi-catch here with illegal argument exception and an exception E. Now everything seems to be fine according to the previous syntax, so why is this not compiling? As you can see, it's giving me error. The reason is you cannot put an exception and its superclass in the same multi-catch, because think of it, this exception is going to catch everything irrespective of its subclass. So you cannot put a superclass and a subclass in the same multi-catch statement. Okay, because the one will catch the other one. Yeah, if you see, except illegal argument exception already caught by alternative exception, they would both be catching the same exception. Okay, so that's another rule. Here in test 7, I've got another example of a compiler error. What I'm doing here, if you look at the first try catch, this one here, this is our normal try catch with a single, not a multi catch, with a single catch. And you see I've got a runtime exception here. If I code here, it would catch a runtime exception with its variable E, its reference variable. And here I'm reassigning E to new arithmetic exception. Now I can reassign it to an arithmetic exception, because remember, arithmetic exception extends runtime exception. This is legal with a single catch statement. But in a multi-catch, I've got a runtime exception and an IO exception with a E here, variable E, just like there. And you'll see I've got a compiler error here. You see here? And it says here in a multi-catch block, the parameter E cannot be reassigned. So it's illegal to do this in a multi-catch. You cannot reassign an exception, okay? And as I say here, assigning a new exception to an existing exception is allowed in the try-catch, but not recommended. It's allowed here, but it's not recommended. But it's not allowed in a multi-catch exception. So in this case, it's not allowed. Okay, in this method named test8, what I'm showing you is that I've got a try and I'm throwing an IO exception here. Then I've got two catches, a single catch and a multi-catch, which is legal. But remember, you cannot catch a less specific exception before the more specific one. So the old rule still applies. If I had to do this, then my error is gone, as you can see. Okay, but the old rule applies. You cannot have something like that. Okay, like that, in other words. So remember, the old rule applies. You know, old rule still applies. You cannot catch a superclass exception before its subclass. What I mean there is you need to catch the specific exceptions before the less specific ones. Okay.